All right, so let's review today. Are y'all listening? Let's review today all the directions for 6-3, because there's a lot of different directions, a lot of different things that we put together. So let's just put it all together today. So here's your vector. It could be in any direction, any length, which is your magnitude. And so the first thing that you were asked to determine was component form. So your component form just means not every vector. So this vector right here, that doesn't mean that P is at the origin. Component form takes this vector, which could be, like, for instance, look at example number 1. Is example number 1, is that vector at the origin? No. It starts at 0.46 and it goes to 0.810. So it is in the first quadrant, and it is going in this direction, isn't it? First quadrant? Should have a positive slope, shouldn't it? And so what we've done with component form is to subtract the initial from the terminal x value, initial from terminal y value, and put them in this form right here. And all this does is take this, which is not at the origin, and it puts it at the origin. So I can take, let's say that this vector was this length of my ruler, and it was originally over here, and this is my origin down here. All we've done with component form is take that same vector, and it would be in the same direction, oh, by the way, same slope. And we just put its starting point at the origin. That's all component form does. Then you had to find the magnitude. All the magnitude is the distance formula. It's really nothing different than what you've learned before. But we did learn that if this is 0, 0, and let's just say, for chuckle's sake, that this is 6, 6. What's 6 minus 0?
It's 6.
6. And what's for the y value 6 minus 0?
It's also
6. So in this case, it was 4, 4, wasn't it? So 4 minus 0 is still 4. 4 minus 0 is still 4. So why do we have to do the distance formula? Can't we just take a shortcut, which I suggested before? Instead of doing all this, couldn't I just have taken 4 squared and gotten 16, and 4 squared and gotten 16? So I could have cut out that step right there. And then simplify that radical. So notation, magnitude is length. Okay, then, so let's say that we take this vector right here. This is not a unit vector. A unit vector then takes us into the unit circle. What is the length of the radius on the unit circle? 1. So we have to learn how to take any vector and convert it into what's called a unit vector. So then on this side, I'm ignoring all, by the way, the vector operations. You don't need me to go over those, do you? Okay. Pardon?
No.
Do you want me to go over them?
No.
I can. Ask me in a minute. I'll go over them after I'm done. So then what we did here was find our unit vector. So we took, and sometimes you're going to be given your vector in component form and sometimes not. These little v parentheses mean it's in component form, meaning it's a vector that starts at the origin. If it's not in component form, they're going to give you 2 ordered pairs, an initial and a terminal point, and then that means that you have to put it into component form here. So there might be an extra step, so be aware of that. If it says find a unit vector, that means that you have to change the magnitude of your vector into 1. And there's a formula to do that, and this was the formula up here. I prefer this one right here. Well, no, I take that back. I prefer that one there. So all you do is you take your component form and divide it by your magnitude. If you don't know the magnitude, you have to find it. So on this particular example, we had to find the magnitude. So we took -2 squared, because we're using the shortcut, 5 squared, and then we simplified that. It didn't simplify because it was square root of 29. And then all we did was divide each one of these by the square root of 29. And I proved to you over here, I was just verifying that the length of this, because all we did was take a vector that was too long and we shrunk it down so that it would have a length of 1. What if it's shorter than 1? Then you're going to increase its length so it becomes 1. So your vector could be shorter than 1 or longer than 1, and to make a unit vector, you're going to change it so it becomes that. You might have to verify. And all you're going to do is take your new component form of that new unit vector, and you're going to put it into the radical, the shortened form of the distance formula. Square each one of them, and then add them together, and it should come out to be 1. If it doesn't come out to be 1, you did something wrong in your original calculations. And so when you're taking your quiz tomorrow, if I were you, and you are making or finding a unit vector, I would verify it somewhere on the test to make sure that you got a magnitude of 1. Because if you don't, you did something wrong, you can go back and fix it. All right, so then, yesterday, we did talk about linear form, right? Linear form is just a different form of the component form. As some of you commented, it looks like it's an imaginary number, right? Think of it this way, it's a little bit more complex looking. But back to here, I told you originally that with the linear form, that I is a vector that goes from 0, 0, because it's in component form, to the point 1, 0. So where is that vector at? Isn't it the x-axis? And then j is coming from the origin and going to 0, 1. Isn't that the y-axis? Doesn't I represent the x value right here of your vector, and doesn't j represent the y value of your vector? So that's really all they've done, is they've basically taken the vector and put it out on the x and y axis into two different vectors that we've combined as one, if that doesn't make it more confusing. And then we had the same operations with linear form as we did with component form, but then we got into these directions. So we took our unit vector, and now we're looking at it in the unit circle. All vectors are assumed to start here on the x-axis, and they go counterclockwise in this direction. They're all assumed to start there. So this is your standard starting position, and they all move in that direction. So what happens if you have a vector that does not have a length of 1? So in other words, it's not a unit vector. We've come up with this formula to allow you to not have to do all kinds of conversions. So if you go back and look at example 6, you were given the directional angle and the magnitude, and you had to find the component in linear form. With a magnitude of 100, it's not a unit vector, is it? Right? So look what happens when we put it in the coordinate grid. We knew that it had to be in the third quadrant because an angle of 210 degrees has to be in the third quadrant, but this length is 100. And so when we found our reference angle, which was 30 degrees, by subtracting it from 180, we realized that our pattern would be -1, rad 3, which is here is negative rad 3, and this was supposed to be 2, but what is it really? 100. So the reason why we end up using that formula from the previous side is because if it were a unit vector, what would we multiply by? 1. But in this case, it's 100. And when we convert a vector in component form into a unit vector, don't we divide by the magnitude? Well, this one though, we're not actually using the component form. What are we using? Sine and cosine. So if I take the cosine, and then I'm going to adjust for the fact that it's not a unit vector by multiplying by its magnitude, then we're going to end up with our proper component form, because remember, we don't know what this ordered pair is right here. We don't know what that ordered pair is. We're trying to find it. And so all we've done is taken our magnitude of 100 and multiplied it by our cosine, as we pointed out earlier when we were going over homework. Pay attention to your signs. And we multiply by the magnitude again, but this time by the sine. Cosine is at your x value or y value. Cosine, x value or y value? X. On the unit circle, it's x. Doesn't it make sense that we'd be going with your I, because that's your x value in your linear form? Sine is your y value, and it goes with j, which is your y value in your linear form. So it really shouldn't take too much for you to memorize that formula or know it, right? And the more you write it down, the more likely you are to know it. Once you have it in a linear form, you can just pull the coefficients out for your component form. And then this one, find the directional angle. They give it to you this. So I actually have the component form, but given any component form, I can always find the angle. Plot the point. Use your trig knowledge or your knowledge of special right triangles to find that angle. Are there any other general questions that I can explain? Like what to do with adding, subtracting, multiplying, dividing, scalar multiplication? Yes. I guess we didn't divide, sorry.
Yeah. I just still really don't understand the whole the V with the 2 lines around it.
All it is notation
Yeah.
that says the length of that magnitude. And they use the notation so they don't have to write the length of the vector is or the magnitude of the vector is. It's shorthand.
So that just means magnitude?
Yep, that's all it means. It doesn't mean absolute value.
Yeah, right.
It looks like absolute
Yeah.
value, it does not mean that. Nope. Any other questions? Anything else you'd like me to explain? Okay, so for your quiz is going to be very much like problems on here, so make sure that you understand your notes thoroughly. If you don't, you need to come talk to me today. And then the 2 homework assignments that I've given you previously, any of those are fair game. None of them have been outlandishly difficult or ridiculous. And then I've given you some additional homework today. So between those 3 assignments, you should be prepared for your quiz. You will get to use your notes, so just make sure that you understand your notes so that you can use them. So if you're having trouble with directions and you don't understand your notes, you're not going to be able to use your notes on your quiz to figure out what the directions mean, right? But you can use your notes, yeah.